In this chapter, we will be looking at the properties of sinusoidal functions. In this lesson, we will be looking specifically at the characteristics of the graphs of sinusoidal functions. To begin, though, we need to introduce the concept of a radian.
So the first thing we're going to do in our look at sinusoidal functions here is to introduce another way of measuring angles. Okay, so angles can be measured in degrees or in something we call radians. Okay, and we're going to see here in a little bit that radians are actually a much more natural way of measuring the angles in a circle. Now, that's not going to be your experience to start off with, because at this point you'll be used to measuring things in terms of degrees. Okay, but you got to understand that there are 360 degrees in a circle. But why is that? Let's maybe ask it like this. Why are there 360 degrees in a circle? I mean, where did that come from? Why the number 360? Well, it turns out that it's based on a mistake that was made a long time ago. The ancient Greeks believed that there was 360 days in a year. Now, they were really close, okay? But they were off by just a little bit here. And they noticed how the sun moved positions in the sky on a day-to-day basis, and that was a degree. And so in the full circle, 360 degrees. Now it turns out that's been wonderful for us, because 360 is divisible by 2, 3, 4, and so on. Like it's a great number. But it's just an arbitrary number that they chose, kind of serendipitous that it works so well for the application that we've created for it. But it's not the most natural way of measuring angles in a circle. Now let's take a look at what a radian is. Okay, a radian is based on taking a ratio that compares the length of the arc of a circle to the radius of a circle. So here we go. And I think it should be pretty obvious that the defining feature of a circle is its radius. Okay, a circle is the set of points equidistant from a given point. Every point on this circle is the same distance from that center point here. The radius is the defining feature of the circle. So it makes sense that when we start measuring angles around the circle, okay, for example, we make this angle theta here, that we would use the radius to help us deal with that. And this is what we do here. Whatever this arc length is from this point to this point, we take that measure, and theta, the measure of the angle in radians, will be equal to the length of that arc divided by the length of the radius. Okay? Now that gives us kind of an interesting situation to start off with here. Let's say, for example, that we've got a circle here. Maybe what I'll do is I'll flip this over. Let's say maybe we've got some sort of a circle here where the radius here is, let's say, 5. And we've got an arc length here. And when I say 5, let's say 5 centimeters. Let's say we've got this arc length here that's 10 centimeters. Okay, then what's the measure of this angle in radians? Well, the angle of that measure in radians will be 10 centimeters divided by 5 centimeters. And so the answer is 2 radians. Now, an interesting thing happens here. Think about what you've seen in your science classes here. Notice that the units here will cancel. And so a radian is a dimensionless measure. In other words, we don't write a little symbol at the back here to indicate that this is a radian. We don't put a little degree symbol. We don't put anything, okay? Because a radian is really just a ratio of lengths, and then those units cancel out here. So anytime you've got some sort of a number here and you know it's supposed to be an angle, if there are no units, it's in radians, okay? And so that's how that works here. Now, let's talk about the full circle here. Let's draw another circle here just to give us kind of a standard point here. So we know how a radian is defined. It's the length of an arc divided by the radius. Well, now we know that there are 360 degrees in a circle. Okay, and that's an important point when you're learning that first little bits of geometry, circle geometry there. That's important to know. So it's got to be equally important to know how many radians there are in the full circle. So let's take a look at this angle right here. Now, that's going to be the length of the arc divided by the radius. Well, in this case, the arc is the full perimeter of that circle, or circumference of that circle. So what's the formula here for the circumference of a circle? Well, that's 2 pi r. And I'm going to divide that by r. Now notice that the two radii there cancel, and we're left with 2 pi radians. So in other words, there are 2 pi radians around the full circle. Now that's kind of an awkward number because, well, pi is that, infinite decimal. It doesn't repeat. So it's kind of a weird number to use, but we typically just use it as that symbol there, 2 pi. And so therefore, we can say that 360 degrees is equal to 2 pi radians. Now, numerically, they're not the same. Okay, numerically, they're not the same, but they represent the exact same thing. 360 degrees is the angle measure if you rotate around the full circle once. 2 pi is the radian measure if you rotate around that circle once. Now, that being the case, we can simplify that a little bit here. If you divide both sides by 2, we get that 180 degrees is equivalent to pi. And that's actually the connection that we want to really kind of milk that idea for all it's worth here. So we're going to flip back. We're going to take a look at this here. We're going to use this idea that 180 degrees is the same as pi, okay, and to come up with, or to show you what some angles are here. So here's 180 degrees right here. Now let's think of it like this. Let's say that I cut this thing in half. What's this angle right here in degrees? Okay, well, that's 90 degrees, okay? So 90 degrees right here. In radians, think about it like this. This is 180 degrees, and I took that and I divided it by 2. So this is going to be pi radians, and I'm going to divide that by 2. That's got to be the same as 90 degrees. So therefore, I can state here that 90 degrees is the same as pi over 2. If I take and look at, let's say, 60 degrees, okay, 60 degrees is going to be 180 divided by 3. Well, I'll do the same thing over here. If I take that and I take pi, divide that by 3, there's that angle right there in radians. So 60 degrees is going to be the same as pi over 3. If I wanted, let's say, 45 degrees, now 45 degrees does kind of an interesting thing here. It actually cuts the circle. Actually, I should have done it like this. It cuts the circle into quarters. In fact, it might be easier if I just clean this up a little bit here. Okay, 45 degrees is going to look something like this. Chop, chop, and then one right here. So 45 degrees would be 180 degrees divided into quarters. So if we take this diagram right here and do the same thing, drop that down, here's pi, quarter, quarter, quarter. That's pi divided into quarters, and so now we can make the connection here that 45 degrees is a quarter of pi, pi over 4. So 90 degrees is half of 180, so it's half of pi. 60 degrees is a third of 180, so it's a third of pi. 45 degrees is a quarter of 180, so it's a quarter of pi. And the last angle that we typically look at here in this little section right here, just because it just shows up a lot, right? And that angle is 30 degrees. Now 30 degrees, if we keep drawing out 30-degree notches here, 30 degrees is a sixth of 180. So 30 degrees is 180 divided by 6. Now, over here for radians, we would do the exact same thing. We would take, there's my pi, and we would chop that into 6 different regions here. So pi over 6. And so then we could say that 30 degrees, because 30 degrees is a sixth of 180, pi over 6 must be the same as 30 degrees. And so we will typically use these ratios right here to communicate the size of angles in radians. Okay. Now, right here is probably one of the reasons why right now, if you were to go out to a hardware store and buy something, you would not buy something in terms of pi over 2 radians or pi over 3. The numbers here are granted a little bit awkward to work with. And the fact that they're written in fraction form doesn't help that at all. These numbers here are a lot more comfortable for us but you should really spend some time and memorize the relationship here. I mean, either memorize the connection between these angles here, or just get it in your head how we're doing this. Okay, we take 180 degrees. Think about how we divide this up into fractions here, and what that would look like if I simply called 180 pi. That'll give you the sense of how radians work.
Now we need to consider what it means to be a periodic function.
At this point here, we're going to switch our focus and to start talking about what we call periodic functions. So we've introduced this idea of a radian, and we're going to kind of leave that for a little bit here. You're going to see it kind of filter into the discussion that we're going to have here, but really we're going to focus more now on what we call periodic functions here. And what we're going to look at is something called a sinusoidal curve. Okay. Now we call it sinusoidal, and you're going to see in a little while here, because really what this is, it is the graph, essentially for the most part, it's the graph of the sine function. So sinusoidal. Okay. The defining characteristic of this curve is that it fluctuates back and forth. It oscillates, goes up and down, up and down. Okay, and it does the same thing over and over and over again. It does this infinitely. Okay, it just waves back and forth. It always goes up to the same height, always goes down to the same depth here. Okay. In fact, if you want to think of it like this, every one of these sinusoidal curves here has really got four distinct parts to it. You might think of it like this. Let's say we start here on that kind of that middle line. This is our midline. You start on the midline here. It goes up, and then it comes down, and then it goes down, and then it comes back up again. Okay, and there are these four motions that create this piece that gets repeated over and over again. Okay, this thing just goes on and on like that. Now, and you need all four of those. Okay, because it's not this piece being repeated over and over again. If it was this piece being repeated over again, the graph would look like this. Okay, but it doesn't. It's these four pieces together repeating up, down, down, up, down, down, up, and so on. And when a graph repeats like that, we call it a periodic function. Okay, so the sinusoidal curve, the graph, okay, the graph of the sine function primarily. Now we're going to see that there are other trig functions that produce the same graph here, but in general we call them sinusoidal. The sinusoidal function is a periodic function. It's a function that repeats itself over and over again over a certain interval. Okay? Specifically, the length, the horizontal length of that piece that gets repeated, which we've just seen is this right here, we call that the period. Okay? And you'll recognize that if you've gone through science, whatever, when you've talked about repeated motion here, you will have talked about the period of some motion here, like a pendulum swinging. This means basically the same thing. It's just another application of that word here. So when we take a look at the graph, okay, there are a couple of ways you can think about this as long as you're getting all four of those motions. So one way of looking at, and you can see right here, this is the sine of theta. One way of looking at it is that you start here on the origin. We go up, down, down, up, and there's my period. Okay, and you would notice here that to go from here to here on our scale that we're given here, pi over 2 to pi to 3 pi over 2 to 2 pi, that this thing goes up, down, down, up, and then it repeats again, and it takes from 0 to 2 pi, or 360 degrees, to do that. So the period of a sine function, a regular sine function here, the period of sine x is 2 pi radians, or 360 degrees. Okay? Now that can be measured a couple of different ways here. As long as I'm still collecting all four bits of those motion. Now remember, that was up, down, down, up. So two ups, 2 downs here. Now over here, another way to kind of identify the period is to take two corresponding points in the motion here. To go from here back down to here, I've got to go up, up, down, down. Again, 2 of each. Okay, and so that's enough to be a period right there. And then this gets repeated over and over again. And that's just another way of looking at it, if you will. And in this case right here, if you wanted to know what the period was, you would simply take the difference between these two values here. Now let's just take a quick look at that. Probably zoom in on that a little bit. The x value right here is negative pi over 2. The x value here is negative 5 pi over 2. Now let's just see what's the difference between those. Negative pi over 2 minus negative 5 pi over 2. Okay, now there's a lot of negatives in there, and just be aware of what that rule is. Negative pi over 2 minus negative is like adding. So negative pi over 2 plus 4 pi over 2. Sorry, I just did it in my head. Negative pi over 2 plus 5 pi over 2 will be 4 pi over 2, or 2 pi. And we'd already seen that from this part of that diagram. Yeah, the period is 2 pi. It really shouldn't matter. If I was to take these 2 points and find the difference between them, again, 5 pi over 2 minus pi over 2, again, I'm seeing 2 pi. And I would see 2 downs, 2 ups. Okay? So that's just another way of looking at that. So one aspect of these sinusoidal graphs is that they're periodic. They repeat. Amplitude. Okay, another characteristic of these sinusoidal graphs is that they've got an amplitude. So this is 1/2 the total height of the function. 1/2. So think about the total height of the function here from bottom to the top. Okay, amplitude is half of that. Now, the reason it's half of that is because of the connection that this makes to physics, okay? And maybe another way to think about it would be like a guitar string. We know that a guitar string vibrates, right? Well, when it's at rest, the guitar string kind of sits right here, okay? And then what we do is we pluck it, we pull it away from the rest and let it go. And then it vibrates back and forth across the rest here. The further you pull it away, the louder the sound. So amplitude is related to the sound, but it's the distance that you move away from that rest position. And so we've just borrowed that idea. Okay, it's not really that this thing was ever at rest, but we still kind of take that idea of pulling it away from the middle there. So one way of looking at amplitude here is it's the difference, or it's half the difference between the maximum value of the function and the minimum value. Okay, so you just take the spread, max minus min is the spread, and divide by 2. So in this function right here, let's just take a look at it. The maximum value, and when we say maximum value, we're always talking y coordinates. Maximum value this one gets to is 1. The minimum value it gets to is negative 1. So for this graph right here, the amplitude would be 1 minus negative 1 over 2. Now again, be careful with the negatives. 1 minus negative 1 is going to be 1 plus 1 over 2, so 2 over 2. And the amplitude is 1. The distance from the middle to the top of that graph, or the middle to the bottom if you will, is going to be 1. All right. Now, one other idea we want to talk about before we're done here, and I've already kind of mentioned it, but we'll talk about it again here, is the median or midline of the function. Okay? So we're talking about the horizontal line halfway between the maximum and the minimum values of the periodic function. So when this thing vibrates, or when it oscillates here, it's oscillating around a certain specific height, kind of the at-rest height. That's the midline here. Okay, and to figure out what that midline is, it's always going to be the average of the max and the min. Always halfway between the max value and the min value. So in this particular case right here, for example, we're showing this. The maximum value is 1. Okay, now this is the same, basically the same function as before, except this is a cosine graph. And if you notice the difference between them, okay, there's cosine, whoops, there's sine, sorry, there's sine. It really has to do with how it approaches the y-axis here. Sine, all by itself, goes through the origin. Cosine, all by itself here, doesn't go through the origin, it goes through 0, 1. And that's it, it's just offset a little bit. Still got that same curve to it, looks very much like a sine graph, so it's still called sinusoidal. But its midline here, and we call this D, the midline here, the maximum value of this graph is 1, the minimum value is negative 1. Divide that by 2, that's going to be 0 over 2, or 0. The median line here, the middle of this motion, is along the line y equals, okay, not x equals, I'm not coming over here and oscillating this way. This thing oscillates up and down, so the middle is a vertical value of 0. Okay? Now you should memorize those equations. Okay? Memorize the fact that the amplitude is going to be the max minus the min over 2. The d value, the median, is going to be the max plus the min over 2. You should have those committed to memory.
For each of the following functions, state whether it is periodic or not.
Okay, so when we take a look at these two graphs right here, remember the question is about which one of these things are they both, or are neither one of them periodic? Periodic refers to the repetitive nature of the graph here, the repeating nature, okay? Not how smooth it is. So in spite of the fact that this is kind of a nice smooth curve here, it's not actually repeating exactly. Now you might say, well, yeah, it does. It goes up, down, up, down, up. But it does it at a smaller and smaller and smaller amount here. It changes as it goes along here, okay? So if you want to think of it like this way, the amplitude of this thing is changing all the time. So no, this one's not periodic. It's not the same thing over and over again. But look closely at this one. Granted, it's not a really nice smooth curve, but notice what it does. Okay, it goes up, hits 1, bubbles up a little bit, drops down, a little bit up again, drops down, kind of a little bit of a weird shake, hits the x-axis again, and then it's the exact same shape. Okay? Now, granted, we're missing this little bit over here, but it's because we're just looking at a fraction of the graph here. But this is repeating exactly. It's going up to the same height. Okay? It's the same kind of a shift over from point to point and whatnot. This one is periodic. So again, don't confuse like pretty with periodic, okay? Don't confuse a graph that does this sort of thing, that does seem to be waving back and forth. Again, if there's any aspect of the graph that changes over time here, then it's not periodic. It has to be the exact same thing, kind of cut, paste, and so on in order for it to be considered periodic.
Determine the period and amplitude of each graph.
So for these questions, we're coming up with the period and the amplitude here. So let's take a look at the period. Look at this graph first here. Notice it's fluctuating up, down, up here. Okay. Now, notice it goes up, it looks like a half here, it goes down about a half. So it's fluctuating the same amount around that x-axis there. So to start here, up, down, down, up. There's my 4 actions here. It goes out to 2 pi, so my period is 2 pi. It's the length of that piece that gets repeated. The amplitude, okay, amplitude is going to be the max minus the min divided by 2. So 0.5 minus negative 0.5 all over 2. Okay, well, that's going to be the same as 0.5 minus negative 0.5 is going to be 1. 0.5 plus 0.5, 1, divided by 2. So the answer here is going to be 0.5. Okay, which is really, if you can see it doing what the graph is doing here. Okay, it goes up to 0.5, from the center it goes down to negative 0.5. The amplitude, half that distance from top to bottom, is going to be 0.5. Here, again, we're taking a look at the period here. Let's take a quick look at it this way. Notice that this graph starts on the y-axis. It starts up here at 1, at its maximum value here. So I'm going to go down to the middle, down to the bottom, up to the middle, up to the top. Notice that the distance here is 1, 2, 3, 4. The distance here is 1, 2, 3, 4. So this line right here, the x-axis, that is the middle. Okay? So to go from here, the top, all the way back up to the top is 2 pi over 3. That's my period, 2 pi over 3. Okay, and if you think about it like this, remember that we said before that pi over 3, remember what pi over 3 was equal to 60 degrees. That means that the period of this thing in degrees would be 2 times 60 degrees, or 120. And now the amplitude is going to be half the distance from the top to the bottom. So my maximum value here was 1. My minimum distance here is negative 1 over 2. So 1 minus negative 1 is going to be 2 over 2, and the amplitude is 1. So this graph right here is probably a little bit more in line with what you would normally expect to be like a question on an exam or a quiz here. Let's just take a quick close look at this. So again, we're being asked for the period and the amplitude. Let's take a look at the period first. Now, notice that my graph, the motion here starts when we look at the y-axis here. It starts at its peak. Okay, and again, we're going to go down, what is it, 1, 2, 3, 4, 1, 2, 3, 4. Okay, so it's going to go down 8 here. So down, down, up, up. So once I get back up to here, there's my full period. Now, I can't read off the graph what that is. Okay, There is no bit of information here. In fact, it runs. They've labeled every other one there. So what I got to do here is I got to be a little bit clever to read that off there. And so what I would do here is notice I've got pi here. And remember that corresponds to about 180 degrees. Well, no, not about. It is 180 degrees, but pi radians. What I'm going to do is I'm just going to count out how many little squares is that? 1, 2, 3, 4, 5, 6. So each little square here is pi over 6 radians. Okay? Now, to go from here to here is 1, 2, 3 of those. Okay? So my period here is going to be 3 pi over 6's. Okay? And now 3 pi over 6 is the same as pi over 2 when I reduce that. So my period here is going to end up being pi over 2. For my amplitude, notice that the maximum value that it gets to is 2 and the minimum value that it gets to is negative 2. So my amplitude is going to be 2 minus negative 2 over 2. So now 2 minus negative 2 is 4 over 2 is 2. So the amplitude is 2. Whoops, can't see that a little bit there. Okay, let's do another one here. Now again, this is a periodic graph. Not the same kind of nice wave as what we've got before. This is like a sawtooth graph. Let's take a look at the period here. Now notice on the y-axis here, it starts right there at the origin. It appears to go, now if I'm reading off the scale the way they want, it looks like it's going up to 10, so 10 above, 10 below. Okay, it's got the 4 motions, 1, 2, 3, 4, and I'm ending up on 8. So the period here is going to be 8. The maximum value, the maximum value that this thing gets to is 10, and the minimum value it gets to is negative 10. And so 10 minus negative 10 is 20, over 2 is 10. So it has an amplitude of 10. Okay, for this particular graph right here, things are offset a little bit. Now to get our period, okay, notice that we hit on the y-axis here. It's usually easier to read it off at the y-axis if you can. It's at its minimum value. It goes up to the middle, roughly, I don't know exactly where that is, I'll figure that out in a bit. Up to the top, down, down. So there's these 4 motions there. And I can read right off this graph that it's got a period of 6. From minimum, up, or down, all the way to minimum again. 6 units horizontally, the period is 6. Amplitude. Okay, this time around, the maximum value that the graph seems to get to is 6. Okay, 6. And then its minimum is negative 2. So my formula for amplitude is going to be 6 minus negative 2, okay, or 8 divided by 2, and that's going to give me 4. Now this time around, the median, okay, most of the graphs that we've looked at up to this point, the median has been right on 0. And in fact, I've been able to come up with the amplitude probably a lot quicker than what I've actually been doing here, just because I can see it on the graph here. Here, my median, the d value, is going to be the max plus the min over 2. So 6 plus negative 2 is 4, divided by 2 is 2. Now what that means here is that if I draw a line, a horizontal line through here at 2, okay, at y equals 2, that is the middle of the graph, okay? So I'm going to be able to go 4 up from there and 4 down from there. The domain, the domain here is going to be x is an element of the reals. It's going to be all real values. This thing is going to wave forever. But the range, okay, and I've already identified the maximum minimum here. My range was negative 2 up to 6. Okay, so those are the pieces that we're looking for here for this particular graph. Now let's take a quick look at this one right here. See if we can read stuff off just the same here. For our period, again, notice that the graph is starting on the y-axis on its... Oh, no, it's not. I'm sorry. That is not the y-axis. The y-axis here is where the 0 is. Here it is right here. You've got to be careful with that. There's the y-axis. It was a little deceiving because that's a little darker. But it starts at its maximum there on the y-axis. It goes down, down, up, up. So here's the next maximum. And from 0, that goes out to 2 pi. So our period here is 2 pi. For our amplitude, the maximum value that our graph gets to is positive 3. The minimum it gets to is negative 3, so it's going to be 3 minus negative 3 over 2, and that'll give us 3. the median, the midline here, now again this one is back to being where it normally is. The median I can kind of read off of that's going to be 0, but we'll do it this way anyway. 3 plus negative 3 over 2. Well, 3 plus negative 3 is 0, divided by 2 is 0, so there it is, right? Okay, the x-axis is cutting this thing in half. The domain, once again, the domain looks to be an element of the reals. We're assuming that the graph continues to wave beyond this. This is just a portion of the graph here. And my range, and again, I've already at this point here identified the range. The minimum was negative 3, and the maximum value was 3. So it fluctuates between negative 3 and 3. Okay, for this graph here, once again, things are a little bit offset. It's not quite sitting where we've had it sitting in the past here. Okay, let's take a quick look. This time the first thing we're looking for is our amplitude. Now if we take a quick look at the graph here, you can see that the maximum value that the graph reaches is going to be 3, and the minimum value it's going to reach is negative 1. So for my amplitude, this will be 3 minus negative 1 over 2. Okay, well 3 minus negative 1 is 4, over 2 is 2. Okay. Now at the same time here, we might as well do the median. The median is going to be the maximum plus the minimum over 2. Now 3 plus negative 1 is 2, divided by 2 is 1. Now I can draw that line through, and it sometimes is helpful for me to do that. Here's the 1, y equals 1, and that cuts everything in half here. Now my period, and actually now that I've got that line drawn in the middle, the period's actually easier for me to see. I'm going to look at the y-axis again, and notice that I'm cutting it through right there at the y-axis, and that is the middle of the graph here. So my motion is going to be up, down, down, up. Okay, those two little bumps there create a full period, and I can read off of the x-axis that that thing ends at 4. So my period, the length of that piece right there that's being repeated, is 4 units. Okay? Now, the other way to do that would have been to maybe compare these minimum bits here, negative 1 and 3. If you just take the difference between those 3 minus negative 1, you get 4 as well. My domain, okay, as it has been, because we assume that these things continue forever, is going to be element of the reals. Okay, I assume this graph goes on and on and on. And my range, once again, I've already identified that the minimum was negative 1 and the maximum was 3. Okay, guys, I needed that to get the amplitude and the median. Now let's take a look at this one. Same thing, we're going to start off looking at our amplitude here. So the first thing I want to do is read off my maximum, and my maximum is 6, and my minimum is 2. Okay, so my amplitude here is going to be 6 minus 2 over 2. 6 minus 2 is 4, divided by 2 is 2. Amplitude is 2. And once again, because I'm using the exact same values, I might as well jump to my median, and this is going to be 6 plus 2 over 2. Now 6 plus 2 is 8, divided by 2 is 4. So the median, or the middle of this graph, is at 4. Now I would probably be smart to draw that line in so I can see where the middle of that graph is. Now it's asking for the period. And again, if I can do it like this, this is probably the easiest way to do it. I'm going to look at the y-axis, and once again, the middle of my graph, okay, is on the y-axis. So I'm going to start right here. Now notice that it goes in a slightly different direction. The last time it went up, down, down, up. This one's going down, up, up, down. But that still covers it. I've still got all 4 of those motions that I need, the down, up, down. The 2 little bubbles. It's in a slightly different order, but that still does it. And I just got to read off the graph. What is that? Well, this is 1.05. This is 2.09. So my period here looks to be 2.09. Now I'm sure that's a nice little, supposed to be a nice little fraction of pi there, but that's what I'm reading off the graph right now. My domain is going to be that x is an element of the reals, and my range, well, the minimum value I saw was 2, and the maximum value that I saw there was 6. So there's my range, 2 to 6. Okay, for this graph here, once again, things are a little bit offset. It's not quite sitting where we've had it sitting in the past here. Okay, let's take a quick look. This time the first thing we're looking for is our amplitude. Now if we take a quick look at the graph here, you can see that the maximum value that the graph reaches is going to be 3, and the minimum value it's going to reach is negative 1. So for my amplitude, this will be 3 minus negative 1 over 2. Okay, well 3 minus negative 1 is 4 over 2 is 2. Okay, now at the same time here, we might as well do the median. The median is going to be the maximum plus the minimum over 2. Now 3 plus negative 1 is 2, divided by 2 is 1. Now I can draw that line through, and it sometimes is helpful for me to do that. Here's the 1, y equals 1, and that cuts everything in half here. Now my period, and actually now that I've got that line drawn in the middle, the period's actually easier for me to see. I'm going to look at the y-axis again, and notice that I'm cutting it through right there at the y-axis, and that is the middle of the graph here. So my motion is going to be up, down, down, up. Okay, those two little bumps there create a full period, and I can read off of the x-axis that that thing ends at 4. So my period, the length of that piece right there that's being repeated, is 4 units. Okay? Now, the other way to do that would have been to maybe compare these minimum bits here, negative 1 and 3. If you just take the difference between those 3 minus negative 1, you get 4 as well. My domain, okay, as it has been, because we assume that these things continue forever, is going to be element of the reals, because I assume this graph goes on and on and on. And my range, once again, I've already identified that the minimum was negative 1 and the maximum was 3. Okay, guys, I needed that to get the amplitude and the median. Now let's take a look at this one. Same thing, we're going to start off looking at our amplitude here. So the first thing I want to do is read off my maximum, and my maximum is 6, and my minimum is 2. Okay, so my amplitude here is going to be 6 minus 2 over 2. 6 minus 2 is 4, divided by 2 is 2. Amplitude is 2. And once again, because I'm using the exact same values, I might as well jump to my median, and this is going to be 6 plus 2 over 2. Now 6 plus 2 is 8, divided by 2 is 4. So the median, or the middle of this graph, is at 4. Now I would probably be smart to draw that line in so I can see where the middle of that graph is. Now it's asking for the period. And again, if I can do it like this, this is probably the easiest way to do it. I'm going to look at the y-axis, and once again, the middle of my graph, okay, is on the y-axis. So I'm going to start right here. Now, notice that it goes in a slightly different direction. The last time it went up, down, down, up. This one's going down, up, up, down. But that still covers it. I've still got all 4 of those motions that I need, the down, up, down, the 2 little bubbles. It's in a slightly different order, but that still does it. And I just got to read off the graph. What is that? Well, this is 1.05. This is 2.09. So my period here looks to be 2.09. Now, I'm sure that's a nice little, supposed to be a nice little fraction of pi there, but that's what I'm reading off the graph right now. My domain is going to be that x is an element of the reals, and my range, well, the minimum value I saw was 2, and the maximum value that I saw there was 6. So there's my range, 2 to 6.
Now we'll introduce the equation of the sinusoidal function y equals a sine of b times x minus c plus d.
All right, now that we've spent some time looking at different periodic functions, and specifically sinusoidal functions, now we're going to take a quick look at the equation of a sinusoidal function. Okay, so sine of blah, blah, blah. And you've got these different parameters included in that equation. We just want to take a look at what the parameters do in light of what we've just been looking at. Okay, so for example, when you've got something that's written out in this form where a sine of b times x minus c, and then you close brackets twice plus d. Let's just throw an example out here. Let's say it's 3 times the sine of, I don't know, let's say 4x minus 5 plus 6, whatever. Just for the just lack of better numbers, there we go. What do those numbers mean in terms of the graph? Okay, well, let's just take a look at this. We'll read this thing through left to right. The first variable that we get into, the first parameter, is the a. Now, a is going to give us amplitude. And we've already seen that that's going to be the max value of the graph minus the min value divided by 2. Now, we put the absolute value around that is because the number that shows up in front of the sinusoidal function could be positive or negative. And all that does is change the direction of the motion here. So for example, a sine graph would start on the origin and it would go up, down, down, up. But if there was a negative sign in front, that would just cause a little reflection here. It would flip over the x-axis, And so the result would be to go down, up, down. Okay, and so this would be what it would look like if the a value was positive. This would be what it would look like if the a value is negative. Okay, it's still a sinusoidal function. It just changes basically the direction that it goes initially. The b value. Well, the b value gets incorporated with the period here. The period of the function is going to be 2 pi if we're working in radians divided by b. Now, if we're in degrees, it would be 360 divided by b. So you have to know what mode you're working in, okay? What units you're using in terms of measuring angles. We're going to skip over c. What c does is it actually causes a horizontal motion in the graph. It'll either move you left or right, okay, depending on the value of c here. But it's not really something that we utilize a lot in this particular chapter because shortly we're going to take a look at what we call exponential, sorry, not exponential, I mean to say sinusoidal regression, which is just a fancy word for line of best fit. We're going to let the calculator do a lot of work with that, and the calculator doesn't use the c value in the same way. It actually ends up multiplying the b value through, and so what you're seeing here is a little bit different. And so talking about c as the horizontal motion right now, it's not going to be abundantly clear as we go through those examples, so we don't typically spend a lot of time discussing that, so don't worry about that. The d value, though, the value added out at the end, once we've kind of closed the brackets on the sine function, that's going to be your median value, the midline. Okay, and that's where we found the max plus the min divided by 2, and that was that line that we drew in the middle. Okay, so now another thing to remember here is that our range, and if you think about how we've been identifying the range here, if this is your midline here, remember what it does here. The graph goes up above that midline and then down below that midline, but it goes up a, it goes down a. So if this is our d value, then our range is going to be d minus a, and then our maximum is going to be d plus a. So that's our range here. The minimum value is going to be negative a plus d, the maximum value will be positive a plus d. And so our range, okay, is going to be that negative a plus d out to positive a plus d. So now we're going to take a look at some examples answering questions based on that particular function.
State the amplitude of each periodic function.
So in this question here, we're being told to state the amplitude. So, and that's really quite easy to do because the amplitude corresponds to the coefficient of the trig function. So in this case, because it's 2 times the sine of theta, our amplitude is 2. Now, a cosine function, and I know we said it before here, it is sinusoidal. It produces the same sort of graph as a sine function. And it behaves in terms of the function exactly the same way as well. The pieces mean the same thing. The only difference is that the cosine function, when you plot it, in terms of its curve, it just starts at the peak of the curve. So it starts high and then drops down, whereas sine starts at the middle, goes up and then comes back down again. But that's the only difference here. So we're still pulling out the pieces the same. So because the coefficient of the trig function is a half, the amplitude is a half. Now over here, similar sort of question, but something you got to pay attention to here, the amplitude, if you look back at the information that we did previous to this, we had the absolute value of the amplitude. Amplitude is always positive. So in spite of the fact that our coefficient here is negative, we're not concerned about that because the amplitude is just the separation from the midline to the maximum or the minimum there. It doesn't matter positive or negative. That negative is irrelevant. So amplitude is just 1/3. And the same thing holds true for that cosine graph at the end there, that -6 cosine. The amplitude here is going to be the positive or the absolute value of that number. So the amplitude in this case is just going to be 6.
State the period for each periodic function in radians.
So in this case here, for all of these, we're going to utilize the relationship that we've been given relating the period to the value of the b, the coefficient of the variable in the trig function. In this case, we see that b is 4. So period is going to be, in radians, 2 pi over 4. And then we would just simplify that to get pi over 2. Or 90 degrees. Remember, pi is the same thing as 180 degrees. So pi over 2, half of pi is the same as half of 180, 90 degrees. Here, the coefficient of the theta inside the trig function is 1/3. That means my b value is 1/3. So period is going to be 2 pi divided by 1/3. Now, this often causes people problems because of the fraction that shows up in there. But when you divide by a fraction, remember that you multiply by the reciprocal. So 2 pi multiplied by 3 over 1 is 6 pi. Okay? So there you go. There's our period for that particular function right there. In this case right here, again, the coefficient of the variable inside there is 2/3. So that means our b value is 2/3. Period will be 2 pi divided by 2/3. And once again, we are multiplying by the reciprocal. So this will be 2 pi multiplied by 2/3. Sorry, by the reciprocal. I just said it and I didn't do it. 3/2. And when you multiply those out, the 2's will cancel, and we're just simply left with 3 pi. And finally over here we've got the cosine of 6x. Again, the coefficient of that variable inside the trig function, that's our b. And period will be 2 pi divided by that b value, 6. And that can be reduced down to pi divided by 3. And remember how that works. Pi is the same as 180, so pi divided by 3 would be the same as 60 degrees.
Identify the characteristics of the following graphs.
Okay, so for the next few graphs here, we're going to just take a look at the graph here and grab all the information that we can out of it based on what we already know about the relationships between the graph and the variables. So the first thing you might want to look at when you see this graph here is you might want to pull out the maximum value and the minimum value. Maximum value that this graph reaches appears to be 4, and the minimum value that it reaches here looks to be 2. Okay, whoops, can't see that. So the maximum value it gets to is 4, minimum value is 2. Now, that gets us a couple of things here. First of all, the median, excuse me, the median is going to be the average of the max and the min. So this is going to be 4 plus 2 divided by 2. So 4 plus 2 is 6, divided by 2 is 3. There's our median line. Now, what I would do in this case here is I would quickly draw a line through at that median value. That's the middle of the graph, so it should fluctuate above and below it by the same amount here. The amplitude is the difference between the maximum and the minimum divided by 2. So 4 minus 2 is 2, divided by 2 is 1. So the amplitude of that graph is 1, and actually that bears itself out here. Here's 3. Each one of these little blocks here, if you just look at the scale here, is going up by a half. So there's 2 of them here, 2 of them here. So yeah, that bears itself out. The amplitude here is 1. Next thing we're going to look at here is period. So now let's just measure this out here. Typically what I would do here is I would look along my line, my midline here. This is where I cross it and I go up, down. That's not a full period. Down, up, now that's a full period. So going from here to here is a full period. Now, I'm not right on the y-axis here, so those don't quite match up here. So let's just take a look at this. How many squares is my full period here? Well, it's 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12. 12 little blocks there. And if we look at this carefully at the scale here, if this is 60, well, it's got to be 30. That's got to be 30. So my period here, there's 12 blocks times 30 degrees. The answer is it's going to be 360 degrees. So yeah, the period of this thing is 360. 360 degrees. Now the value of b, now let's think back here. Period, I showed you before, was 360 degrees over b. Now previously what we did is we did 2 pi over b, but remember 2 pi and 360 are the same thing. So if I tell you right now that that period is 360, okay, then 360 over b is the same as 360. Well, cross multiply and then divide, and we get that b is equal to 1. Okay, b is equal to 1 there. Now, lastly, take a look at the range here, and then you can read that right off the graph here. My minimum value is 2, my maximum value is 4. That's my range. I'm going to go from 2 out to 4. Okay, so that's all the information for this one. Now we're going to take a look at a couple more graphs here. Okay, here's the next one. Same thing, I'm going to start by identifying the max and the min values. The maximum value here looks to be 1. And the minimum value down here is -3. Okay, so now we can come over here and grab a couple of things. Our amplitude is the difference between those. Okay, half the difference between those, so it'll be max minus the min over 2. Okay, well 1 minus -3 is going to be 4 divided by 2 is 2, so there's my amplitude. And at the same time, I'm going to do my median because I'm going to use the same variables, or sorry, the same values, I should say. So the median is going to be the max plus the min over 2. So 1 plus -3 is -2, divided by 2 will be -1. And so like I've done before, once I've got the median, I'm going to come back to the graph. I'm going to draw that line in. Here's that -1 line. That is the middle of the graph. So it should go up 1, 2, 3, 4, and down 1, 2, 3, 4, the same amount. Okay, because that line should be right down the middle. Next thing we want to look at here is the period. And so on the y-axis, I'm starting right at the peak. Okay, that's convenient. So now my 4 motions here go down to the middle, down to the bottom, up to the middle, up to the top. There's a full period. And I can read right off the graph that that is 2 pi. The value of b. So remember, period is equal to 2 pi over b. And we just discovered that the period was 2 pi. So if I cross multiply and then divide, I get that b is equal to 1. Okay. Oops, not -1, 1. And now my range. Last thing I want to look at here is my range, and I can read that right off the graph. I go down to -3, up to 1. So -3 less than or equal to y, less than or equal to 1. Let's do one more. Okay, this time the graph is entirely above the x-axis here. Got a little bit of a context to it. The maximum value that this graph gets to is 20. The minimum value that it gets to looks to be 4. Okay, which is enough to allow me to come over here and to figure out, again, those two pieces, the amplitude and the median here. Amplitude being the difference between them divided by 2. So 20 minus 4 is 16, divided by 2 is 8. The median is the average of the two, so that's, sorry, I'm starting in the wrong spot there. 20 plus 4 divided by 2. So 24 divided by 2 is 12. And as I've done before, I'm going to come over here, find my 12, and I'm going to draw that line in. And I'll just double check. 1, 2, 3, 4 blocks above is the maximum. 2, 3, 4 blocks below is the minimum. Perfect. That's the amplitude. That's the way that works. Now my period. Once again, I've got a graph that starts on the y-axis at its peak. So 1, 2, 3, 4 motions. I back up to my peak, and I can read right off the graph that that's going to be 12. So my period here is 12 units. So what's b? Well, period is 2 pi over b. But I know that the period is 12, so this will be 2 pi is equal to 12b when I cross multiply. And now I'm looking for b. That's the unknown there. So 12 times b is 2 pi, so I'll divide. 2 pi divided by 12 is equal to b. And I don't mind the fact that there's a pi in there at all. I'll just leave it in there. I'm not going to do anything with it. But I've got this 2 over 12, which can be reduced to 1 over 6. So 1 times pi in the numerator over 6. And now the range, again, I can read that right off the graph because I know it goes down to 4, up to 20. So this is going to be from 4, which is less than or equal to y, up to 20. And there's my range.
Identify the characteristics of the following functions.
Now we're going to do a really similar thing to what we've just been doing, but the information we're going to grab is going to come out of the equation, not the graph. So here we go. So you can see everything here. So here's my equation, 2 cosine of 3x minus 8. What's the amplitude? Well, the amplitude is associated with the coefficient of the trig function. And so the number up front here is 2. That means my amplitude is 2. Okay. What's the value of, like you can't tell what the period is. That's an important point here. You don't know what the period is. You got to do a little bit of work to get the period. But I do know the value of b. I can read that right off. That's the value that's in front of the x inside the trig function. That's 3. But as soon as I know that, okay, now I'm good for the period. Because remember, period is 2 pi over b. And so this will be 2 pi over 3. Okay? 2 pi divided by 3. Now, if you think about it like this, pi over 3 was 60 degrees. 2 of those, in degrees, this is going to be 120 degrees. That's what that means. 2 pi over 3s. Now, d is the number that we are either adding or subtracting out behind the trig function, outside of it. And in this case here, that's going to be negative 8. Now, I got to put some stuff together to get the range here. That d at negative 8 represents the middle here. And the amplitude tells us how high above that and below it goes. So my function is going to go like this. So it's going to go 2 above that and 2 below that. Well, what's negative 8 and then go down 2 more? Well, negative 10. Okay. What's negative 8 and go up 2? Well, negative 8 plus 2 is negative 6. So my range here will be from negative 10 to negative 6. Let's do another one. Sine of 1/2 x minus 45 plus 3. Now, it's 45 degrees. You can't hardly see that. It didn't print very well. Okay, amplitude. Amplitude is the a value. It's the coefficient of the trig function. And there's no number out front. So if no number is written, let's go back. Let's think. What number does that mean? Well, it means 1. Period. It's too early to figure out what period is. I need more information. I need to know what b is. Okay, b is the coefficient of the variable inside the trig. Okie dokie. Well, it's the sine of 1/2 of x minus 45 degrees. So b is 1/2. Okay, now if I know that, period is now I'm in degrees here. I hope it's clear here that I'm in degrees. Okay, because there's a degree value in here. In the previous question, I didn't know. So when I don't know, I'm going to typically assume that it's radians at this point, because we're trying to teach you radians, and so that'll be my go-to here. In this case here, the presence of that 45 degrees means I'm in degrees. So instead of being 2 pi over b, this will be 360 over b, and in this case, b is 1/2. Now, 360 divided by 1/2 is the same as 360 times 2, or 720 degrees. And so there's my period. Period is 720 degrees. D is that value that we add after we've taken the trig function, after we've applied that. So in this case, it's going to be that 3, positive 3. So what does this mean in terms of our range? Well, here's our midline here. This is at D. Sorry, D equals 3, I should say. And then my amplitude tells me that I'm going to go 1 above that and 1 below that. Okay, up 1, down 1. So from 3, what's down 1? Okay, well, I hope that's clear. 3 minus 1 is going to be 2. And then 3 up 1 will be just 3 plus 1, or 4. So my range will be from negative 2 to 4. Okay, in this next one, they do something a little different here. They throw that negative out front. Okay, but remember, amplitude isn't affected by that. That negative simply refers to a direction of motion. It doesn't affect the amplitude, so my amplitude is still going to be 4. Don't know the period yet, but I can see what the b value is when I work inside that trig function. The coefficient there of x, when I multiply it through, is going to be 2, so b is 2. I can see from this number right here that we're talking degrees, so we're in degrees. So period will be 360 degrees divided by b, and b in this case is 2. So 360 divided by 2, that's 180 degrees. So that's the period. This function repeats every 180 degrees. The median is the value that we're adding outside that trig function. So in this case, it's going to be 7. And now what does that mean in terms of range here? So here's 7. My amplitude was 4. Now don't worry about the fact that it had negative in front. Don't worry about that at all. That's not relevant to answer these questions. Okay, I know from 7 I'm going to go up 4 and down 4 with every sinusoidal function. So from 7, what's down 4? What's 4 below 7? Well, 3. And then what's 4 above 7? 11. So my range here is going to be all values from 3 to 11 inclusive. Okay. Now one more. Oh, ooh, this is a complicated one. It's got all sorts of little fractions in here, but it's actually not that big of a deal. It's not really all that important here. The amplitude is still the coefficient of the trig function, so it's going to be 1/3. Just read that right off. Don't know the period, but I can figure out the value of b. B is that first number that we see inside that trig function. And so this is going to be 1/4. Notice that the number that I'm giving you here is in radians. There's no little degree symbol with it. And every time you talk about fractions of pi, you're almost always talking about radians. So period here would be 2 pi over the b value of 1/4. Okay, now let's think about that. 2 pi divided by 1/4, that is the same as 2 pi multiplied by 4 over 1, or 8 pi. So that's my period, 8 pi. The median is going to be the number that's just hanging out back there. And I just had to get rid of that so I could see it's clearly going to be -1. And so that -1, there's that median line. And remember, my amplitude is how far up I go above and below that. So I'm going to go up 1/3 and I'm going to go down 1/3 from -1. Okay, so to go down 1/3 from -1, okay, is going to be -4/3. That's -1 minus 1/3. And to go up 1/3 from -1 will be basically -1 plus 1/3. That'll be -2/3. And so there's my range, -4/3 to -2/3.